الشيطان الرجيم بسم الله الرحمن الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وضعها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان فبأي آلاء ربكما تكذبان صدق الله العظيم جزاक अल्लाह खैर। तो इंशाल्लाह आपके लिए कुछ थोड़ी सी हाउसकीपिंग के बारे में बताता चलूँ। और हाउसकीपिंग के सिलसिले में इस तरह होगा कि जो क्वेश्चन आंसर्स हैं वो आप चैट फीचर यूज़ कर सकते हैं और उसमें आप एज वी गो अलॉन्ग आप चैट में अपने क्वेश्चन आंसर डाल सकते हैं और डॉक्टर साहब फिर टुवर्ड्स द एंड उसका जवाब भी देंगे। और अगर इंशाल्लाह अगर टाइम होगा हमारे पास तो फिर हम माइक्स भी ओपन कर सकते हैं और टुवर्ड्स द एंड वंस दो रिटन क्वेश्चंस आर कंप्लीट तो आप जो है वो अपना क्वेश्चन भी खुद से पूछ सकते हैं। इस प्रोग्राम के दरमियान में एवरीवन विल बी म्यूटेड और ताकि आप जो प्रोग्राम है हमारा वो कंटिन्यूसली जो है वो प्रोग्रेस कर सके। अगर आपने अगर जूम यूज नहीं किया पहले ज्यादा जो कि मोस्ट पीपल आर वेरी फेमिलियर विद तो अपना आप जो व्यू है वो एडजस्ट कर सकते हैं। स्पीकर्स व्यू या व्यूअर्स व्यू आप अपना जो टॉगल क्लिक करें ऊपर 3 बटन भी होते हैं तो उसमें अगर आप स्पीकर व्यू पे करना चाहें तो समटाइम्स people are stuck in a different view but you can change it the way you want to. Again chat में आप अपने क्वेश्चन आंसर डाल सकते हैं और प्लीज डू नॉट फॉरगेट फीडबैक। आप इस फॉर्म में डाल सकते हैं और या फिर हमें हमारे जो नाज़ली को या किसी भी हमारे बोर्ड मेंबर को आप जो है वो फीडबैक जरूर प्रोवाइड करें। काशान को दे सकते हैं आप। तो इस I think that should be all and with that I will turn it over to Nazli for her president's note.
Thank you very much, Shahid. Assalamu alaikum, everyone. First of all, I would like to thank all of you for taking time out from your busy schedule on weekend. And I know cricket match bhi aa raha hai, but I'm sure you will not regret this webinar. This is our first time in NEDAC history that we got the chance to collaborate with NED और Dr. Farrukh का बहुत शुक्रिया कि उन्होंने अपने busy schedule में से हमारे लिए time निकाला। As many of you know, I was in Pakistan for NED Centennial Celebration. वहीं पे मेरी डॉक्टर साहब से मुलाकात हुई थी and I learned कि NED में क्या wonders हो रहे हैं. So I thought it's good idea to invite him to share his knowledge and his experience with our members. Thank you, Dr. Saab, for joining us. मैं थोड़ा सा बता दूं कि हमारे साथ नॉट जस्ट NEDians हैं, हमारे साथ यहाँ पे UET एलुमनाई एसोसिएशन है, काफी एक्टिव है, उनके भी प्रेसिडेंट हमारे साथ हैं और उनके और बोर्ड मेंबर्स भी हैं। हो सकता है कुछ लोग हमारे साथ UK US से भी हों, मैंने अभी सबके नाम नहीं चेक किए because we always share our information with other alumni so we all can get benefit from each other. So without further ado, I would like to invite Kashan. Kashan हमारे PDC member हैं, PDC Professional Development Committee member, and he's going to give brief introduction of our presenter today, and then Farrukh Saab, aapke liye. Kashan, over to you.
Good morning, everyone, and welcome to this webinar. I would like to introduce Dr. Farrukh Arif. He is Associate Professor at NED University. He is also the designer and director of state-of-the-art Virtual Reality Center at NED University. His area of research interests include automation, infrastructure management, virtual reality, augmented and mixed reality, building information modeling, and sustainable construction. Dr. Arif has more than 50 publications, including journal papers and funded research project reports. He is currently leading multiple research and development projects worth more than 55 million rupees, funded by different organizations in Pakistan, including Higher Education Commission. Dr. Arif has also been honored with several awards, including Chairman Institution of Engineers Pakistan Medal for Best Paper, and Outstanding Doctoral Research Award by Florida International University, to name a few. Please join me to welcome Dr. Farrukh Arif. Over to you, Dr. Arif.
I hope I'm clear, first of all, to all of you.
Yes, we can hear you, Dr. Arif.
Yes, we can hear you.
First of all, I would like to thank NED Alumni Association of Canada for providing me with the opportunity to mingle in with my own people of my own. I mean, when I say people of my own, I mean both from perspective of being Pakistan, and also majority of us are from NED. So I welcome you all. And again, once again, Nazli specifically, thank you very much for providing me the opportunity to share whatever we have been doing at NED. So basically today's webinar is about virtual reality or immersive visualization, to be specific. And the title, as you all know, is Concepts and Applications of Immersive Visualization for Engineering and Sciences. This is going to be the presentation outline for today. Mainly, I'll discuss with what immersive visualization is all about and different types of immersive visualization that we have. And then I'll talk about the virtual reality applications for engineering purposes and science purposes as well. Their concepts and some developed examples that we have basically developed at NEDVR Center. Also, we have been working recently on augmented reality and its further derivative form, mixed reality applications in engineering sciences, and I will discuss the concepts and develop examples for that as well. One of our key product is interactive patient simulator, which is also a kind of visualization. So I'll discuss and go over the that patient simulator and how it can help in medical science. Then we would have a discussion about how can we move forward further and utilize this visualization for further innovation, specifically in engineering and sciences domain. And then the forum could be open for any kind of interactiveness and on the topic of how can we collaborate and any on the questions and answers that you may have in your mind. So starting with immersive visualization, when we talk about immersiveness, basically we are talking about being in a different world, being immersed or being sunk in a different world. And when we talk about visualization, so the visualization is any technique, any kind of technique that can create images, diagrams, animations, not just for the sake of developing images, but to communicate some message. Now that message could be of any kind. That could be of pretty normal message, as we typically do. For example, WhatsApp, we all use and we use emojis. And the emojis are a way of communicating our feelings or what we are thinking through different clip art. So that is also visualization. So when we combine immersiveness with visualization, what we are talking about is that we are immersing or syncing our mind or how we look into the thing into a different world, into a different environment. And that is what we can call as immersive visualization or immersive environment. It can be applied to any different types of categories. For example, I just mentioned mixed reality, typically known as MR, VR, virtual reality, augmented reality, AR. And we create through these tools different experiences that would make us feel in a surrounding or in an environment that is not real, but looks like to be real. So it's a virtual environment, but we feel it that we are transformed or we are kind of translated into that environment. Now, when we talk about the categories of immersive visualization or in general visualization innovations, typically they are mixed, augmented, virtual reality, augmented reality, and immersive. Immersive itself is as a terminology that is utilized to represent all these kind of environment. But immersive on its own is also a type of its own category or its own category. So what do we mean by virtual reality? The virtual reality provides us with full immersiveness, which is near to high realism or is highly realistic experience. And typically this is achieved through wearing of some kind of head-mounted devices. In computer science or in general, we call them as HMDs. And then what happens is that it basically closes us out from the actual world and takes us or our sight into a different virtual world. You must have heard of different technologies like Oculus Rift or Oculus of different types. Nowadays, the most recent one is Oculus Quest, and then there is a company HTC Vive, Samsung Gear, etc. So what it does is that it closes out your line of sight and takes you all your thinking and look and sighting process into a different world. This is also possible with different other types of system, which is, for example, one such system, and we are very fortunate to have it at VR Center as well. That is called projection VR system, in which you don't need head-mounted devices. Rather, through a whole studio environment, you do need some glasses, and you are transformed as a group into a different world. And what we utilize is the basic physics, the angles. We create a corner like this, and that corner or cave environment, as we call it, gives us an opportunity to fully immerse a number of people at a time into a virtual environment. So this is, for example, this picture is of VR Center itself. We do have a projection VR system environment, corner cave environment. We have a two-screen system. And all of these systems which you look into, this is also our own picture, where a subject is basically wearing HMD Oculus Rift device and is being immersed into a virtual environment. So all this is related to virtual reality. When we talk about augmented reality, so it could be of different types. Now, what do we mean by being of different types? Augmented reality actually serves contextual information through smaller devices, or rather different devices than what we call as HMD. Now, augmented has its own offshoots in mixed reality as well, but you must have seen using the simple mobile phone, I'll show you the example as well, to create a virtual object on top of a real object. For example, all of you nowadays, like everyone, are fond of taking good pictures. But you must have seen, specifically the young people, children, they like to superimpose some kind of clip art, some kind of 3D art onto their own pictures. The cameras have filters, and they use filters to create, funny images or whatever you call it. So that is kind of a augmented reality, starting with the 2D environment. But then augmented reality and its offshoot mixed reality is also possible through different HMD kind of devices. Famously, the best known, the best available is the HoloLens. So HoloLens 1 was there, and then HoloLens 2, which is currently the Microsoft device is considered to be one of the best device with regards to mixed reality, and according to certain scientists and researchers, it is the only mixed reality device. Now, what is the difference, between the two? Is that when we talk about virtual reality, the person is transformed into a virtual environment. Well, when we talk about the mixed reality, the virtual objects are transformed into a real environment. So if I say that when I'm looking into a virtual world, I would be fully immersed into a virtual environment where everything would be not real but virtual, but would feel like a virtual. Only I would be the real person. But when we talk about mixed reality, all around me, the environment would be real. And within that environment, I would have superimposed virtual objects. So that is called mixed or augmented reality. Both of these have, of course, you can understand different perspective of looking at the things. And hence, different types of experiments could be performed using the either of the environment. And we'll discuss certain experiments later in the slides as well. The mixed reality is kind of, as I said, is an offshoot of the augmented reality. It's kind of a mixture of augmented and virtual reality. So what it does is that both kind of visualization are mixed together to form a kind of a context for the real world. And this provides us kind of mixed opportunities or further enhanced opportunities to use the virtual and augmented environment together to perform different experiments. When I say experiments, it's not just related to only hardcore scientific experiments, say for engineering and sciences, but also psychological impacts, also other kinds of similar things. And it is being vastly used by different institutes and organizations and medical health professionals as well for the same purpose. Moving on, when we talk about immersive visualization can be a term that could be used for MR, VR, and AR to create experiences that user feel is surrounded by the experience. Now, you must be thinking that there is a very little difference between the different types of categories that I'm discussing. And that is true. The reason is because each one of them is a kind of a derivative of the other, or each one augments the other. But when we talk about immersive visualization, to be exact, which is being explained in this particular slide, it does not have a 3D environment to be exact, or it does not have kind of full immersiveness, or does not provide you full immersiveness as a subject. But what it does is it does provide you an experience which may or may not need HMD. So it could be provided on a 2D screen as well, and it might be provided in a virtual environment as well. So if you would look at the applications around the world, typically the two categories are more prominent. The reason is the same, because they have a little bit of more difference from the perspective. One is the virtual reality and the other is the augmented reality. But both as categories are part of concept of immersive visualization. Now, when we talk about virtual reality applications in engineering sciences, there are many. I'm going to discuss a few which we have been able to explore over the past few years. In the later part of my presentation, I would also discuss what do we have at VR Center and a little bit of its history. But you can realize that we were, just to give you an idea, we were established and formally established in 2018. So since then, we have been working on a number of projects, and I've picked those which could be of interest for you and in general, all the audience related to engineering and sciences. So I'll discuss the example of virtual reality for infrastructure management, virtual reality for capacity building, in electrical engineering for training of the gang, and then virtual reality for cost planning and STEM programs that we have been able to develop to make students and early age students and high school students understand different scientific concepts. So starting with VR for infrastructure management, I must mention and give credit of this particular project we conducted with a company called AI Engineers, which is a renowned company in USA. and we had a collaboration regarding the project where we created integrated infrastructure immersive visualization. So what was the plan was that at the AI engineers, they are very hard, they are very much willing to change and collaborate with other organizations. I must give them credit, and they had a lot of data set with regards to infrastructure when it comes to 3D point cloud data and laser scanning data. What they wanted is to take it to another level, where they wanted that all this data set, which was being collected from drone, from laser scanner, and converted into a virtual environment so that the client can visualize it in the VR and make better decisions. So with regards to one of their projects in Connecticut, they had data set, the geographical, or you can say the planar data set, aerial data set from the drones, and then they had the 3D point cloud scanning and also information model, building information model that they were that was developed for that particular facility as planned. And what we did with them was utilize that data set and create an immersive integrated visualization and check it for the capacity building. This was the integrated kind of framework that we used. So drone-based data, the BIM data, the laser scanning data, we converted into a compatible interface. When we talk about compatible interface, we are talking about these data sets are of different types. And they are of different perspectives. We combine these perspectives into a compatible interface using the information modeling software, and then created a virtual reality visualization that can provide, number one, better visualization, and that can document as-built generation, and hence could be utilized in future for better decision making and further inspection as well. So this was just a quick project overview. It was a bus facility in Connecticut, where they had a number of facilities provided for the bus station. They had data set, as I said, from laser scanning, number of flights were conducted, and point cloud data. They even had the MEP data. All these data sets were combined. Number one, this is for UAV data, for example, and let me just play it for you. So this was 3D point cloud data set that was generated, and this 3D point cloud data was generated out of the drone data set, or unmanned aerial vehicle, as we call it. And it provided us the data set for the surroundings, that is the building surroundings throughout. And this data set then, along with the laser scan data, with the laser scanning was done to basically digitize the current or existing facilities, all dimensions in terms of 3D point cloud data. And then moving on, the BIM visualization, which was as planned data set. So this was the as planned data set that was basically developed in the building information modeling platform. And it had all the detail as far as planning is concerned. So all these things, or three major data sets, were combined into what we call as integrated visualization for virtual reality. So you can see that, and this is one of the experiments or tests that was performed while we were sitting here hosting the data, and the AI engineers were sitting. So we can measure different dimensions on site. We can go around in virtual reality. Of course, in this particular video, it would not give you that feeling that we may have in the virtual reality environment, but this is collaboration between the two ends. One of the partners was sitting in US, the other partner who was hosting, which was us, was sitting in here, and we were collaborating and experimenting different aspects of that facility, walking through the whole environment. And that was being done over the internet in virtual reality environment. So virtual meeting was being conducted. This particular second study was basically, and it's already a published work, was related to infrastructure visualization for efficient infrastructure management decision making. What we did was, and those of you who are familiar with, say, Karachi, just near the NED University, we have a place called NEPA, It's an institute, but now it is known as NEPA. So we had that bridge information available, famously known as NEPA bridge or bridge at the University Road. And we tried to convert it into its information model, and then and create a virtual reality visualization for the same in projection VR. Why projection VR? Because we wanted to check whether this kind of experimentation could be, or this kind of visualization could be beneficial for the capacity building of bridge inspectors, for example, or the engineers who are involved in physical condition inspection of the bridges. So what we did was that we took the plans, created the 3D model of this whole bridge, and also took the Google Earth data and combined the two data sets together and went through the different asset modeling steps, embedded the rating system into the tutorial model, NBI rating system, if you must be familiar with National Bridge Inventory, and created a tutorial model of the bridge in projection VR environment. Then we also, what we did was we hypothetically created certain defects in that bridge and created another model, which was of which we call as the inspection model. And then in a 15-minute session, just to give you an idea, this is the whole modeling exercise. This just a walkthrough. Again, of course, we cannot have that real feeling of virtual reality in 2D environment, but at least you can have a walkthrough experience. So this whole bridge embedded onto the available Google image of the terrain. This is whole Gulshan Iqbal area, mainly 13D area, and beyond that University Road, NEPA area. And we created its visualization into a virtual reality environment. After creating these models, what we did was that we immersed a number of engineers into different sessions. So a 15-minute session for visualization training were conducted, in which the tutorial model was explained for the rating system, different parts of the bridges. And then in the second stage, the same 15 people, that is the capacity that we have to immerse in a single go, were asked to rate the bridge condition. So you can say 7.5 and 7.5 or 8 and 7 minutes session, 15 minutes total. And then they basically provided their feedback with regards to the use of this virtual reality environment, as well as with regards to its comfort, experience, etc. in this process. And we got very good results. So the effectiveness was reflected through comfort aspects. For example, how much comfortable it was it used to use that gadgets from engineering perspective. Then if there was any dizziness, because when you do experiments like this, of course, what we are doing is we are playing with the mindset and the vision or the sight, not the vision, but the sight, the focal length, as we call it in physics, of the people. And not many people might be comfortable with that. So we asked different questions on rubrics. And also we basically took a little test of their knowledge retainage with regards to the second module that was inspection module, and whether in the inspection module they were able to rate the infrastructure correctly or not, because we created the hypothetical defects in that. And those who were able to retain, we calculated the percentage of that. And this provided us with the feedback that yes, this projection VR to be specific and virtual reality environment journal is a very good platform to train, say in this case, bridge engineers, or do the capacity building of the engineers with regards for those aspects of engineering which may have required them to go onto the field and learn in a very difficult environment. And this environment provides or avoids going into the field for that reason, for the training reason, of course, and can give them more room to experiment and learn into a safe environment as far as the training is concerned. This particular study is already published in a very famous journal of IT, which is called in Education and Information Technologies. If any one of you would like to have the access to that, I can provide you, or you can always search it over the internet and it will give you the whole paper. Another study that we conducted what was with regards to the use of virtual reality for better cost planning, specifically in the conceptual or detail engineering phase. The conceptual engineering phase, that is the start of the detail engineering phase. And what we did was that we performed certain, being a researcher, if you have to have a hypothesis, you have to basically prove it from statistical and probabilistic perspective as well. So we conducted a hypothesis survey with regards to whether visualization affects the cost related or cost planning related aspect, specifically in infrastructure or in mega projects. The idea was that if we can, or the hypothesis was that there are many factors related to visualization which hinders engineers and other stakeholders to take better decisions at the cost planning stage of its product. Now, the product might be building or might be any kind of thing. Of course, me being the civil engineer had focus in the building. So if we can create immersive visualization at those stages rather than having visualization on just paper of a particular design, then it may lead us to better decision making, specifically with regards to cost. So we formed a focus group, and we also conducted an industry-wide survey to find out or elicit information that whether, number one, whether there is a lack of visualization with regards to cost-related decisions, and number two, can visualization of a type that is immersive or virtual reality in this case improve this process. So these two hypotheses were evaluated over a number of surveys. The data set is provided, and also we had different focus group to get immersed into a innovative environment. There is a current, this is under construction, almost done. At that stage, it was at the planning stage or the conceptual or engineering phase at that time. We created information model for that facility with the Nanotechnology Center. And then from the drawing, there were many changes that were being identified. I'll show you that actual drawing in a later slide, where the engineer and the architect and the owner were corresponding to each other with regards to different dimensions of that plan or building. So the design was getting changed again and again because of the different perspectives. And there were different changes. For example, if you look at this change one that happened after we immersed people into the virtual reality, there was a beam which had a conflict about its depth. So the architect thought that it is deeper than the others somehow, and it would not look good, and it might not be a good place to have that beam, and requested the structural engineer again and again, where the structural engineer argued, no, this beam would not create any aesthetic problem. I mean, the common typical architect consultant debate that we have in civil engineering. And what happened was, another thing was with regards to the stairs with balconies. So there was a view from the stairs, which was an error in the drawing, was not being highlighted in the 2D drawings, but was highlighted because of the dimension. There was an overhanging slab, you can say. The dimension were less accurate in the drawings with regards to how the draftsman drafted it and marked it. And there was an overhanging section of a kind which created a balcony-like visualization from the stairs. So what we did was that we generated this whole environment, the points of conflict, into VR. And at first we conducted certain pilot sessions, whether these kind of problems were there in the drawings. And then we conducted, after the pilot session, a total session. So this was the drawing that I was referring to. If you see, all the drawing notes are there on the structural layout for the slab framing plan. A number of comments were being done, and this particular page, which I have took a snapshot of it and put it in my slides, it was going back and forth every other time. And it took a lot of time for both the architect, the consultant, the designer that is, and the client to come and agree on certain points. So there was a kind of a engineering conflict, you can say, or scientific conflict, not that there was a fight. And what we did was we tried to resolve it through design review session. So if you look at this girl is the moderator of the design, and this is the architect, this is the designer, and behind the girl there is the client representative, mainly NED representative in this case. And they were immersed into a virtual meeting utilizing virtual reality. And rather than discussing these problems onto the planar drawing, they were immersed into a 3-dimension, or you can say virtual environment, 3-dimension to start with from the model and into the virtual environment. And the moderator basically walked them through the whole building layout or building plan or the building itself in virtual environment. The role of the moderator was not to influence the mindset of the consultant and the architect and the owner, but rather to facilitate them with respect to the aspects of using the virtual reality, because all of them except for one were using it for the first time. And then I would quote you in an instant where, if you remember in the previous slide, I talked about that beam. The architect went under the beam, that particular beam, by herself to find to maybe prove a point that she was right. And she looked like this on the top in the virtual environment, and suddenly she said, oh, this beam is not that deep as I thought. And this was the catching point of our study. That particular matter, which was a very small matter to start with, was hanging over for a longer period of time. And there was a conflict because she always asked to remove that beam. And the consultant who was in the virtual environment, actually they can talk to each other as well in the virtual environment. He right away said, see, I was telling you that this beam was not of that of a problem. So you can see that that conflict or that disagreement, as I said, we may say, was lingering on for a longer period of time, which would have delayed the detailed engineering phase to be completed, and which may have had remained there even maybe after the bidding phase or the start of the construction, and may have resulted in certain kind of changes. But at this point, when we immerse these stakeholders into virtual environment of the same, and as I said, conducted the design review in the virtual environment, they were able to resolve and understand each other's position very easily and resolve their problems easily. So we calculated the cost impact of that. If it would not have been resolved, then what would have been the cost impact, and basically compare it to as cost saving. Majority of the examples as I've given you so far are related to civil engineering, but we were recently able to work with the local electricity company, K Electric, and we were able to generate a virtual reality capacity building tool. Many of you might be electrical engineers, so you would have an idea of VCB trolley. So the electrical technicians are given training on that VCB trolley, and there were a couple of routines that were to be modeled. So what happened that they had models available. There is an academy with the K Electric, which is called DNA, Distribution Network Academy, and they have good training facilities. They have models and laboratories. But what they wanted is to change this. They had two components in the courses. One was related to the capacity building in their classroom to the technicians, and then the other was on the hands-on training. So what they wanted was that if the classroom training could also be converted into a kind of a combination of theory and practical. And we generated a visualization for them, which was switchgear workshop visualization. Just to give you an idea, there were different routines. I'm giving you just one clip set of the same. So you would wear and identify the HSE or PPEs, then you wear it, then you go into the switchgear room. You basically, I will show you later on, pick up the tools, then you connect it to the VCB trolley. I'll wait for that scene to come on, and so that you can have. So the user, after having the PPEs worn, The user will go into the switchgear room, and from the table he will pick up the I forgot its name, but I think it's called the tying rod or something. Maybe one of you can identify, and then it goes to the VCP trolley because it starts with that. So it would connect it to its the switchgear to charge it. It gets charged manually, and then it would be revolved, and the switchgear would start. This is the training that they do on the physical equipment. But for every type of switchgear, they would need to have the physical model of the same, which is a constraint with many of the hands-on trainings, not only in engineering, but in medical science as well. So what they wanted is to test whether VR could be utilized and train their and also train their technicians on the same. And then in future, they would not need further models of different types of switchgears that they may install in different parts of the cities. So that would give them a lot of saving with respect to every time when they have a kind of a new type of equipment, they would need the equipment in their lab as well. But by having virtual reality, we can create any such new equipment into VR environment, through asset modeling, and we would not need the physical hardware to be available, which can save a lot of cost. Then we do have a STEM program. This one is a little bit older. Just recently, I was not able to incorporate this into my slide, but just recently we also extended this. This particular was, we do have different STEM programs for high school and school students. In fact, tomorrow morning, we have a visit of a number of school students as well, where we immerse them into VR environment from different perspectives. Now, this is to give them an idea that, okay, number one, this is also an engineering world. And number two, they can have a better idea of different theoretical aspects that they learn in their books. So what we did was, to start with, we worked for a Suparco competition, and we created we showcased it in their competition as well, and we created this visualization, which was to show the impacts of ocean tides, or rather the relationship between the ocean tides and bulging of the earth. So what we created was a description of the solar system, and then this description of the solar system was basically to apprise the students of the basic aspects of basic components of the solar system in VR environment. And then we take them to different environment, for example, to the seaside, and show them how these physical concepts impact, or the bulging of the earth in this case impacts the high and low ocean tide environment. And this had, for example, if you see this particular scene, so the subject gets immersed into a water body, sea body, and then that person can visualize these impact, in this case, the impact of bulging of earth and the creation of ocean tides. So this was to have an idea or give an idea to students. We use it in our STEM program regularly. Whenever students come, we do show them that the theoretical concept is specifically related to the classical science, where, I mean, we all know that there is force, and we see the force, but we are at difficulty at that level to visualize, okay, what do we mean by force? Or we do know that there is potential energy and kinetic energy, but then theoretically we do know, but practically or visualization wise, we are often short on ideas. So VR environment can fill up those gaps. And that is what we have done. And just recently, we have been able to complete a space mission, specifically for Moon, where different scientific experiments that were performed by different space expeditions, specifically to Moon, have been converted into a VR environment. Hopefully in the future, or some of you may visit us sometime, we would show you that as well. where the student gets immersed into a training module. And then once they get familiar with the space related aspects, then they are transported into a space shuttle onto the moon. And then on the moon, they perform certain external experiments or outdoor experiments on the moon, actual experiments that were performed by different scientists and expediters in their expeditions in the past. And then they perform certain laboratory or space station based experiments as well. And we have a scoring system behind that. When you perform good experiments, you get the score and there is a leaderboard. So through the gaming environment, what we have been able to do is to create an application which could make students' interest at a higher level as well, and also make them work with those experiments that may have required them to go to that environment physically. As in the case of moon, it would be possible in near future, or it is already possible. But for them at school level, at high school level, it is a wonderful aid to learn those concepts in a cognitive psychomotor manner through the virtual reality. Now, moving on to the part where we would discuss the mixed reality applications. We had project with the Ministry of Science and Technology where we have focused on the use of mixed reality for construction project progress visualization. So we have generated different mixed reality models through HoloLens, through mobile, and I'll discuss those. In mixed reality, you know that I already explained that what mixed reality can do is that with different textures, different colors, different types of tagging, as well as different layers, you can combine all of these concepts into mixed reality and into virtual environment, and then superimpose that virtual environment onto the real environment. If you remember at the start of my presentation, I mentioned that mixed reality is basically a combination of augmented and virtual environment. And since both of these forces combine together, both of these capacities combine together, it gives a much more opportunity than just the augmented reality environment. So what we have done is in mixed reality, that we generated the information model, we performed the scheduling for that particular project model, we integrated it through the virtual reality or mixed reality development softwares, to name a few, Unity, and then there is Unreal and other softwares. And using their plugin, we have created mixed reality environment for the HoloLens, or mixed reality application for the HoloLens. Other than that as well, we have developed the mobile-based application. I'll show you a picture or two where we have the mobile camera just used as a tool, as a lens on top of the paper, and we can have the actual 3D model superimposed onto the plan. And that is also kind of a tool that can be utilized by engineers on tabletop environment, where they do have meetings and can discuss the use, the different aspects of the project in mixed reality. So, for example, this is one of the trials that was performed, not the trial anymore. I'll show you the final product as well in the later slides. This was an under construction site where we provided the QR code for geographical tagging. Once they are scanned, the 3D model or information model is superimposed onto the real environment. And within that real environment, whatever object has been, or whatever part of the project has been constructed already, the layer for that could be turned off, and the remaining as planned part could be visualized, superimposed on top of the actual progress made so far. These particular videos are for the stage where we had only visualization of the same. But this was initial our own application. I showed you one of the commercial applications to start with, because what we did in the project was to first test different available applications. And for outdoor, usually the HoloLens nowadays is being utilized more into the indoor environment, specifically for MEP when it comes to building projects. But we created our own application where we can turn off and on the layers, provide different colors to the different building elements. And you can see that through the HoloLens, of course, this is the screen recording of the HoloLens. On the real side, we can visualize whatever has been constructed through the glass. And on top of that, we can close the layers which have already been constructed. And the remaining work gets superimposed, geodatically superimposed onto the virtual environment, onto the real progress made. Now, after this, so this was the whole project so far, and it's a G+2 project for which one of the floor is completed. The whole project was monitored every week or every 10 days whenever there was a significant progress made on the site to document its progress. So what do I mean by documentation? Was at different stages of the project, whatever was constructed was mixed with whatever was remaining. And then not only this was just visualization, but adding a value to this, we were able to develop the measuring tool into our application as well. So when we measure the as planned remaining, or when we measure the as built already, we can change the color. There are many options available in this particular augmented reality application. Because of the shortage of time, I'm not discussing everything, but you can turn on or off the layers. You can measure the beam, the column, it's the height and its depth, different aspects of whatever has been constructed. And we compared the progress made, progress calculated with the application. We compared it with the actual, or what we call as manual monitoring, and we were able to get very good results. There was an error of only 2% among the two measurements. That was to validate if we can use the mixed reality for progress monitoring and progress visualization on site or not. One thing to add is whenever we do that progress visualization as shown in these particular pictures, we also document that onto the spreadsheet. So whatever measurements that we made, there is an option in that application. When we basically turn that option on during the visualization, mixed reality visualization that is on site, it gives us an Excel sheet or CSV file that we can later on analyze for different purposes as well. But when we compared the beam and column progress made in this project, you can see the snapshots of it being measured manually. As I said, there was only an error of around 2%, which was very good. And that 2% we also investigated was mainly related to the geodetic placement of the model. Sometimes the hindrance on site, like the material being dumped, the type of shuttering, the background of that site and other such obstacles do provide us some errors in the placement of the model itself. So once the model is correctly placed, the measurement would may not have even that 2% difference in the progress monitoring. So that was a very successful project. The other thing is, already I mentioned that on tabletop environment, this is specifically for collaboration during the design stage. This particular, again, this is for the same building which we experimented. We had a foundation layout plan. And on that foundation layout plan, when you look through your mobile lens and the application that you develop, again, the application developed with Unity, from any angle, you can look at the 3D model of that particular project. And you can turn on and off the layers, or it can show you the developing model of them. You can see in the video as well that it provides us with the sequential, or what we call as scheduling-based scheduling-based progress visualization of the same. So from foundations to the planes, to the columns, to the slab framing plan, it gives us the sequence or scheduling-based progress visualization, probable progress visualization of that facility. And through that, on tabletop, when the engineer and consultant and architect and the client are working together, they can just visualize, okay, how different aspects of that building would look like, and any kind of conflicts or errors could be reduced. So this was also one of the experiments that we have been able, and we have developed this application. Other than that, I'll give you an example of interactive patient simulator. This is one of our featured products. You know that everything got disturbed during the COVID. So one of the major or the key impact was on education. Still it has. I mean, the aftermath of this, all of us can feel the way children around us have to make an effort to go back to the physical learning environment mentally. I'm not talking about just physical, but mentally. But during that time period, that particular challenge also, that particular problematic environment also challenged us to come up with different solutions. And one such was our collaboration with one of the local companies who were interested in innovation. And we created what we call as interactive patient simulator. In interactive patient simulator, basically it's a medical training tool. The idea was that we have trainee doctors and we do have medical students. They typically have to learn different practical aspects on a human body or on a, you can say, a dead body, or on different models or simulators, physical models simulators. But if in the classroom, those theoretical aspects could be converted into the gaming environment, and the gaming environment can also test not only the cognitive skill sets, the mental remembrance that we call as cognitive of those medical students, but also how they can perform in decision making through physical means. So this is what we combine into what we call as interactive patient simulator. It's a complete tool for which we do have the capacity to model different cases. Of course, we first developed the case for a particular patient who came into an emergency room environment, looked like a COVID patient, but actually had asthma problems. And whole case history was developed with regards to its what kind of dialogue or diagnosis, whatever diagnosis would be performed, the physical examination required, the monitoring requirements, diagnostic requirements, tests and other kind of diagnosis, treatments, and the reporting. And the challenge of 20, 30, and 40 minutes were created. I'll show you the video. By the way, this is all all the different products are also available on our YouTube channel. I'll show you the video for this particular patient simulator. And what it does is that through that challenge, a doctor or a trainee doctor rather have to go through whole of the simulation and take decisions with regards to his or her cognitive skill sets, and also take decisions in the timely manner for that patient. And there are high priority or first priority, second priority, and no priority actions that are embedded within this particular software. And the doctor has to, or the trainee has to decide which question to ask, for example, during the dialogue phase, which physical examination to perform with respect to how the patient is responding. So the patient actually responds in voiceover, the patient responds. It's a very real environment, and we do it with the touch screen, or you can do it with any mouse-based system. It doesn't require you to have a lot of gadgets. It's a plug-and-play kind of a software. And behind the scene, the performance of the doctor or the trainee is being monitored by the software itself, and it's noting down how many first priority and second priority and third priority dialogues or treatments or strategies were done. And at the end of the simulation, if you are able to perform it, say within a 20-minute challenge or say 30-minute challenge, whatsoever you have selected, you get a report card for that performance that can give you an idea of how well versed you are with regards to that particular treatment or that particular patient's case. And this gives not only an opportunity for the learner to decide in a kind of a environment, but does not require you to have physical patient, so you are not afraid of making errors, but also the trainer to evaluate the performance automatically. So this is what we had in interactive patient simulator. I'll show you the video. Let me switch over to the video.
Patient simulator is a medical tool for training and assessing trainees and doctors for clinical scenarios in emergency room environment. It involves assessing the patient's medical condition, performing some medical procedures for diagnostic purposes, and finally making a differential diagnosis on the basis of which a report is generated. The report determines the accuracy of the assessment made. Then reflect. Initiate the history-taking procedure by pressing the dialogue button. Understand the patient's medical condition and clinical history with the help of the listed categories and their respective questions.
I don't usually take medication. I only take when I have these crises. No. I feel
procedures such as airway observation, pulmonary auscultation, checking pupillary life reflex, abdominal percussion, and much more can be performed to further determine the patient's symptoms. A wide range of tests can be performed.
So just in favor of time, I scrolled it through quickly a little bit, but I can always give you, if you search on the YouTube as well, NEDVR Center, so you will be able to find out the link, and different product videos are available on our YouTube channel, but I'll also post it in the chat box later on. So coming back to the last part of my talk, and then we can have the open discussion or as per the routine. Basically, I showed you different ideas and different applications, some selected which we have been able to cover do so far at the VR Center. Many of the other application development and other visualization development is in the process as well. Just to give you a brief history of how this all VR Center started. So basically, you know that engineering is all about, or learning of the engineering is all about having proper visualization, both in thinking sense and both in the sighting sense. And that gives me an idea that many of the engineering problems, when we are trying to provide the solution, are lacking the proper visualization or the way we should look at it during the planning stage or during the development stage, to be specific. And then later on as well, when you want to digitize the current state of the things. But what it does is that it lack of such visualization at different stages of the project's development or at different stages of the product development do leave certain gaps that can basically charge you or charge the system later on. And that is not a good thing, or that is a kind of a lack of strategic assessment. So visualization, because you know that we used to seeing is believing, visualization can, or immersive visualization to be exact, can overcome these kind of problems. And that is where we started with the idea of establishing this particular facility, which is called NED VR Center. As I said, it was established in 2018. We have different systems available at the VR Center, starting with the virtual teaming system, through which I'm just also conducted the webinar. We do have interactive panel as well. We do have different walking VR systems equipped with the Oculus and other kind of HMD devices. We have a projection VR system, as I mentioned earlier, which can immerse 15 people at a time to make group immersiveness. We have different design and modeling softwares, passive 3D screen, which does not require any kind of gadgets. It's basically a marketing tool, and one of these software companies gifted it to us to evaluate its use in engineering and sciences interventions, where you do not need glasses. Rather, it gives you a 3D environment, pitch dark black environment, 3D visualization with the naked eye. We do have augmented reality and drone based systems as well, through HoloLens, through mobile-based and tablet-based augmented and mixed reality devices. And when I say the devices, I do not mean just the devices, I also mean the capability to do same. Within the VR system, we have been able to, through different projects, have been able to establish an energy efficiency audit system, not directly related to what we have been discussing today, but since it utilizes IoT and sensor-based and visualization techniques for virtual and on-site energy audits, I thought that I should include that as well. And there is a small startup in the name of BEES, Building Energy Efficiency Simulators, through which we can perform and provide services to both for research and for professional field as well with regards to energy, building energy efficiency, that is. At NED VR Center, we do have different programs, including the Experience VR program for school and college students, where they come in at the center, spend a whole lot of time at the center, and use that time to generate different ideas, how visualization can, first of all, experience the virtual reality, different applications that we have and that we've developed, and then also come up with ideas. And then these basically students and college and high school and university students can also become a human resource in the future for such development as well. We do have a very good program called Imagineering, Virtual Imagination for Engineering, in which we provide free of cost apprenticeship opportunity, 40 to 60 days, to university students, to not only from NED University, but from all around Pakistan, whosoever wants to adopt it. So what we do is that in the Imagineering program, interest-based program it is, we enroll different engineering students at their third year or final year level, and they come in and join us for 40 to 60 days, in which the first week or so, they basically develop idea with myself, thinking about how can they intervene. And these are just with zero level knowledge of virtual reality many a times. And then we assign mentor to them, and that mentor and that particular trainee, or you can say apprentice, basically work with the facilitator or with the mentor and develop a small prototype application. That way, that person also learns through different aspects of the development, but also develop a prototype that could be enhanced in the future with the same collaboration. We do provide services for the professional services for the construction industry with regards to visualization. Me being the civil engineer, this is our one of the product. And then building energy efficiency simulators, I already mentioned. We do have different number of publications. That is just to brag about for our different types of work that we have been doing. We do have a number of projects. Recently, we have been working on these different projects with Ministry of Science and Technology, with Higher Education Commission. We had a good media coverage, had been having a good media coverage with regards to our project and with regards to other such. And these are just a few partners, or you can say collaborators, who have worked with us on different projects in the past few years. So this is basically from my side. I hope I did not take much more time. I see that we are already 9:13, but still I think we have good 20 minutes to have some interaction, and if there are questions to be answered. Thank you very much.
Thank you, Dr. Saab, for such a great presentation. I have a few questions from our members. I just would like to start with a couple of questions I have. I'm wondering if how many disciplines currently takes advantage of this facility at NED University? And the subsequent question is, what are the current bottlenecks you have in terms of technical hardware, softwares, and internet speed, etc.?
Both of them are very good questions. With regards to the disciplines, of course, at NED we have number of disciplines, and all of them. This is a university level center. Not only university level, but I must mention that this kind of facility, to the best of our knowledge, do not exist anywhere in Pakistan for sure, and also it's a unique facility in the South Asia region. The disciplines are not limited. As I said, this is a university level center. University has established its own self, and we have done projects with computer information systems, computer information technology, mechanical engineering, electrical engineering. I showed you a few examples, one of the examples. Other than that, urban engineering, civil, of course, we already have electronics. I may have forgot some. So all of these different disciplines, major disciplines, are covered under these centers. And the way we work with that is not only the students are involved, but the faculty is involved. For example, the space program that I was just mentioning, I was not able to include that into our slides today, but that is developed with the CIS students, and we have a faculty collaborator from that side. And then our team from VR center side, so we provide them with technical and equipment-wise facilitation, and they end up developing these different types of applications. Likewise, one of the projects that I just mentioned, CPEC CRG projects, it's a collaboration between the two centers, VR center itself, and then we have a national center for artificial intelligence. Within the part of that, we have the neurocomputational lab. And both of these, the neurocomputational lab and VR center jointly bid for that project and won that project, in which we are working together. So from the center's perspective, the neurocomputational and VR center join hands together. From faculty perspectives, civil engineering faculty and computer science faculty, electronics and computer science faculty have joined hands together. So I think this can give you an idea. Other than that as well, we have, I mean, maybe it's the wrong word, we've encroached into medical science as well. So we have collaborated with the different medical professionals. Of course, NED hasn't been a medical university. We do have a biomedical engineering program, but as a medical science, we are not a medical university, but we have collaborated with medical professionals and come up with this interactive patient simulator. And also we are working on the virtual patient simulator as well. So discipline-wise, there is no limitation. The second question, I think, with regards to bottleneck, when it comes to the bottlenecks, the human resource for this kind of development is not readily available. So majority of these applications that we have been able to develop through our Imagineering program, as well as through different projects, we have taken up the raw human resource. By raw, I do not mean that they're not engineers, but in terms of virtual reality understanding and immersive visualization understanding, they were raw. And then we trained them hands-on over the period of time, either during their Imagineering collaboration or later on in their projects, or later on in the funded projects when we hired. And that is I will not say bottleneck, but that is a challenge. So when you need to have human resource, first you need to train them over a period of time, and then they become a good human resource in this area of field. So we do have at our staff computer science, computer engineer. We do have urban, we do have civil, we do have information technology engineers. All of these people mainly are part of our team at the moment, working on different projects at VR Center. I hope I answered. Maybe if you have.
Thank you so much. You very well answered the question. Now going to our chat box, I have a few questions here. So the first question is from Awais Mangal. I'll read the question to you. And I think there are a couple of questions from Awais Mangal, so I'll try to combine those. My understanding is that virtual reality works with meta model generated using available existing data. I was wondering if your research involved creating the meta models and how many different algorithms. If yes, do you use genetic algorithm, neural network, or radial basis function in generating meta model and hence the visuals from virtual reality?
Thank you very much. Yes, currently we are working on one of the projects in which we are utilizing artificial intelligence. Specifically, we are going to use analytical neural network, image processing in combination, uh, and come up with visualization of periodic or prediction visualization of deterioration in a facility. So we are working on a project where we are using, and that neural network also doesn't only get data from the observations or measured, but also from the census-based data. So embedded sensors would be utilized to do parametric evaluations over the period of time, and then this simulation image processing would be combined into a neural network, which would give us the image-based prediction, and then it could be utilized for creating VR visualization. So yes, we are working on that, but not all of the project require us to do that. When we talk about static models, then you don't need. I mean, whenever it comes to the prediction and genetic algorithm, generating algorithm rather genetic algorithm, then yes, we are using. I give you one example. Other than that as well, we are, you know, that Meta has been there for a longer period of time, but recently had got more attention. We are working on developing a few things which can be embedded into metaverse environment, and the tools that can be used with rather than individually into a metaverse environment. So one is the data side of the meta that I explained, and the other is the environment side of the metaverse that we are exploring at the moment. The only thing is how to trade in that environment. We all know crypto, but there are certain restrictions when it comes to the use of crypto in our environment. So yes, we are exploring and working on that small tools for developing of metaverse environment as well.
Thank you, Dr. Saab. The second part of his question was, are you engaging or inviting data from the industry? I think you covered it in your presentation, but if you want to explain further on it.
Yes, we have worked with, as I said, a US company, few Turkish companies, other, I mean, Canada, the queries come all the time. You know, when it comes to the professional work, we have been engaging with different clients. Some of them go through, some of them may not go through, but we have worked with the industry in US, in Turkey, in Pakistan. We are currently working with some companies as well. With the IPS, we also work with one of the companies. So we have been, and then the other sources of, for us being at the university, the other sources of funding or working with respect to data and money both together is through different R&D agencies, research and development organizations as well. And we have been fortunate in that. As far as projects are concerned, we have got projects from HEC, from Sindh HEC, from Ministry of Science and Technology, and from industry. I can also name a few, but some I named. Some of them I'll rather keep silent on that, but we have been working with a number of companies, not only in civil engineering, in computer science, in medical health and mental health, psychological training side as well.
Awesome, thank you. We know the matter of confidentiality, you are right. So yeah, you explained well. So other question is from Sharif Saab. He's asking about examples in electrical engineering for virtual visualization. Any projects in Pakistan or in the world you are taking up? You mentioned about the K Electric
Yes,
as well.
we
right?
work with K Electric for capacity building for the switchgear room, and is exactly VCB trolley training. So we are well versed with that. I work with electrical engineering department, our dean and his team on developing this, and we work with the K Electric Distribution Network Academy for that to create a prototype visualization. So if any of you would like to have collaboration with us, it would be more than welcome. Yeah.
Farrukh Saab, we lost your screen.
I think somebody has shared his screen, so I don't know. somebody called Ata Malik. Yeah.
Yeah, there is a screen share here. Please remove that screen share, Mr. Atta.
Maybe by mistake.
Yeah.
Kashan, you can continue your question. We have only very few minutes left. So Farrukh Sahib, if you can be a little precise.
Yes, I'll try.
Sure. Sure.
Because I want to cover all the questions.
Let's
there are
let's have that. Let's have the what they call it in quiz shows, the T20 round. Yeah.
So the next question is from Khalid. How we define VR versus simulation module?
Actually, VR is a derivative of simulation, but when we talk about simulation, it could be just data simulation as well. When we talk about VR, it's the data converted into visualization simulation. So that is, I think, would be the shortest and sweetest answer to that.
Awesome. Thank you so much. I have no further question on chat box. So what we are going to do is maybe we can take questions from our members who are joining this webinar at the moment. Or
yes, I have 3 people who have raised their hands. So I can start with Kareen bhai. Please be precise with your question because we have a very limited time. Yeah, I ask you to unmute.
Thank you. Very, very short. And as you know, many things came in my mind. And first of all, it's very heartwarming to know that my alma mater, there's lots of good things happening there and great things happening. And a few things came in my mind when I saw your presentation is, for example, you gave reference to MRI, CT scan, or ultrasound scanning and everything. Basically, what I see is, there is a tool, and with time, it's becoming more and more powerful tool. And of course, it's a collection of data. And also that's becoming, with the digital revolution, it's coming very, very, powerful. So this is what I see. So as you know, the internet, before it became public, it was already in use by defense. And I think it's the same thing here. This technology, where you are, basically doing the, in this case, it's the immersive visualization or something like that, but a long time ago in the defense, what they did is they had lots of air photos and everything, and they used a stereoscope to do the analysis and everything. My question is very, very simple. Is this concept is completely new, or this is the advancement into already existing, the technology or something like that because of the digital revolution? Thank you.
Thank you very much. It's a very good question. You are right in saying that theoretically it always existed. I'll give you an example, which might be very naive to understand, but all of us see dreams, right? So that is also virtual reality to be exact. With regards to the scientific technology, yes, visualization did exist, but with the evolution of the technology, we have got more opportunities as far as technology evolution in hardware as well as software and the development capacity is concerned. So we can combine and create virtual environments or immersive environments for different complex problems. So it is kind of both. The foundation was there, but the evolution and the new technology has taken it far, far away from what existing knowledge was all about. So you can say it's a derivative of the existing foundations, but not exactly the old version of the visualization itself.
Thank you, Dr. Saab. Sharif bhai, you can unmute yourself and please be precise with your question.
Yes, can you hear me?
Yes.
Dr. Saab, thank you very much. It's a very nice presentation. I learned a lot, but my question will take a very long time for discussion. So I would really request you if you can share your phone number with me, your contact number, and also I would like to come and meet you in NED because it will be a long discussion what I have in mind. Okay, so I close my question here. Thank you very much.
Okay, thanks. I think this is Khalid bhai, Muhammad iPhone. You can unmute yourself.
Yeah, I think I did it.
Yes.
I'm trying
you
to.
go ahead.
Yeah. Okay. again, thanks for the opportunity. My question is related to the building you are referring near NEPA, whether I noticed that the architect was confused about the dimensions of the beam. So that was actually a little, I'm surprised. Was Revit software was used, which actually gives the specific dimensions. So why the architect was confused? And why the Revit software, which is a 3D software, was not used, which is in market since the last probably 30 years. Dr. Saab, thank you very much.
Sir, it was actually not NEPA related project. These were two different studies. So one was the bridge study. This particular building was being planned at NED. And you are right, the information model was being prepared. But again, the visualizing of the information model in the 2D screen was not enough to be seen. When the third dimension, that is the height, when you go under that dimension, then the architect was able to understand the point of view of the structural engineer. So it was not the case that, and while specifically in this case, the information model was not being initially used. We basically prepared the information model of this planned facility for the purpose of the study. But when we made the architect see it on the screen as well, it was not that clear. But when the architect went herself down to the to under that beam, and she looked at like this, and she said, no, it's not that deep. So it's just the matter of perspective. It's not the matter of knowledge or understanding of the architect, but it's just matter of perspective. Sometimes people do not see things in a proper perspective because of, I don't know, environment was missing.
Okay. Yeah. Thank you. Thank you very much.
Maybe architect they didn't have their own model up to that time.
Yeah, looks like that way. Yeah. Thank you. Thank you, Nazri.
Oh, I know we are about to finish. Our time is now 12:30. I have one more question from Mr. Rizwan here. He's asking about the laser scanning tools for converting into digital, what you are using in your facility.
Okay, at the moment, we had a laser scanner Farrukh, but we are going to Leica. The laser scanning basically gives you point cloud data. So there are many commercial softwares available with the Autodesk as well. You can go and take up a recap. But other than that, there are certain freewares as well. Depends upon what actual building you are trying, or building or facility you are trying to scan. And if that particular hardware is compatible with that particular software as well. So if you just look at one of the products I already named, I didn't want to, because I don't want it to look like if I'm at marketing something, but yeah. But if I don't tell, then Rizwan would not agree. Okay, he would say, I don't know, but I'm just joking. So there are freewares available as well on the net. If you just search point cloud processing, you would find out those data sets, those softwares.
Thank you, Dr. Saab, for such a great presentation. I would give it to our President Nazli for ending remarks now.
Thank you, Kashan. Thank you for doing such a great job as a moderator for our program. And now I just want to thank Dr. Saab. I think this 1 hour didn't do justice with your knowledge. We can sit down here and can hear you for hours. So just want to thank you first for taking time out from your busy schedule, and just want to thank to all other participants. Special thanks to our UET friends. Irfan Saab, आपके लिए भी एक इसमें you can take out one thing from this, especially okay, this center is available if anybody wants to do internship or that 60-hour type training Dr. Saab mentioned. आप UET से बात कर सकते हैं, and NED is available for that. And that's it. I think I thought maybe we ran out of time because of lots of questions, but we are on time. Thank you, Dr. Saab. Thank you very much. Just one further information. We will share this recording little later with all of you, and Dr. Saab is available if you guys have any questions. couple of seconds. Yeah, he's back.
Mhm.
Dr. Saab, you want to say a few words at the end?
Thank you very much again, Nazli and board members of NEDAC to provide with me for this opportunity of sharing. I tried to basically showcase whatever might be of interest. There are many more things. For that, I have shared the website, my email ID as well, and the YouTube channel link as well if you want to have a visit. There's a little bit of information and newsletters and everything available to us. And you can always contact Nazli. We have become very good friends. And she has forced me to call her Nazli